Frankly, 70% of our world today suffer from the negligence of SHM systems. Have you ever heard of SHM before? So, SHM stands for Structural Health Monitoring Systems. In our project, we have integrated a fully secure SHM system with the help of IT devices. As shown here, those pictures illustrate the results of the lack of SHM, causing damaging of infrastructures, bridges, and of course, many human injuries. But what if they were maintained by SHM? Lives and costs will be truly saved. Our main inspiration to do our project was a tragedy that happened recently in our country. Tens of innocent children's lives were lost in a school trip to a famous dam that collapsed underneath them, due of course to the negligence of SHM systems. Next, in the block diagram, I'm going to show you the summarized circuit of our project. Our circuit basically contains 3 units, Unit 1 and Unit 2, which each has a microcontroller and an array of sensors and a LoRa module. They gather information from the sensors and send them to the 3rd unit using LoRa, Unit 3, which also has the LoRa and the GSM SIM900 module. The cellular GSM sends all the data gathered in Unit 3 to the cloud and the database, where the data analysis happens and where then data is classified into 2 major classes. It's either healthy data or not healthy data. If the data is healthy, no further action is needed. If the data is not healthy, an alarm is generated. Here, we are showing you the bridge we have used to test our circuit, in which our circuit was implemented on.
Let's go back in time. Our project was initially well-trained for a month on a lower-level maintained infrastructure, which was a rock wall for a bench. We wanted to highlight that our system is applicable to different terrains if well-trained. In addition to different terrains, we have took into consideration that different atmospheric conditions and different volumes, like busy time during rush hours and calm early mornings. For instance, the gauge strain sensor, we will explain later, produced different values when more vehicles were on a bridge.
Here we can show you the first unit that was implemented on one side of the bridge. This unit has a sound sensor, temperature and humidity sensor. It has 4 accelerometers, as we can see here, attached to different parts, and 4 strain gauges, along of course with the LoRa and the multiplexer to link the accelerometers all together, the 4 accelerometers. We also have attached a portable power bank for the power source. Of course, all of those data is gathered here from the sensors and it's sent using LoRa to our 3rd unit, which is located on that building. Not to forget that LoRa covers up to 10 kilometers. Here we can show you the 2nd unit, Unit 2, which also has the same exact sensors of Unit 1. It's located and implemented on the other side of the bridge. Data is collected here also from the sensors, and also data here is sent to our 3rd unit. As we can see here, we have the different sensors and the different strain gauges, each attached to a part with the 4 accelerometers, just to specifically detect the data. After that, we can see here we have our 3rd unit. Our 3rd unit contains a GSM module, a LoRa module, we have the Arduino, and we have external power attached to it because it takes 12 volts, not 5 volts, so we needed the help of a battery. Data is being here received from the first 2 units. As you can see here, we are receiving the data from the first 2 units that are located on that bridge.
Okay, here we can see the output of the unit 3, the serial output of the unit 3, which has the data that are being sent from the unit 1 and unit 2 using the LoRa chip. So the data that we have is for the sensors, the strain sensors, the temperature humidity sensor, accelerometer sensors, XYZ, and the noise sensor. These data, of course, are being received on the unit 3, and the unit 3 is sending all of these data to the cloud. The cloud that we have used is the Microsoft Azure. The Microsoft Azure, we had to create a Linux machine, and we have, of course, created a Ubuntu Linux machine. So, for easier interaction, we have converted the Ubuntu Linux machine from the command line interface to a graphical user interface. We can connect to the Linux machine now using RDP after we have converted to a graphical user interface. The RDP connection, of course, using the public IP address of the Linux machine. After that, we connect to the machine. We can see that it is a graphical user interface now. And after that, we can see inside the machine that we have used the phpMyAdmin database. phpMyAdmin database, in order to use it, we had to create 2 code files for unit 1 and unit 2 for differentiation purposes, of course. We had to create 2 files, and we can see all of the data are being received here in the database for the unit 1. We can see that the temperature, humidity, accelerometer, noise, strain sensors, all of the data are being received instantly after it receives the unit 3, and it is being sent to the cloud. We had used the HTTP GET method to capture the data. On the left side, we can see SHM and SHM2, which has unit 1 and unit 2 databases to differentiate or separate the data from each location. We can see the PHP code that we have created. Yes. Okay, so the PHP code that we have created, if you can go back. So the PHP code that we have created, it's a simple code. First, we had to connect to the database using the credentials of the phpMyAdmin. Then we had to put the HTTP GET code and arrange all of the data that we want for each unit. So we had created 2 files. You can see unit 1 and unit 2.php. These are the codes for each database. After we receive the data, we analyze it, and we can send it to, of course, to a tool. We have used the Grafana tool to visualize the data, and we have used another tool for furthermore analyzing the machine learning tool that we will talk about it later. We can see now the unit 2 out.
Okay, let's go back now to phpMyAdmin. After creating 2 databases for Unit 1 and Unit 2, we created columns for each sensor. As you can see here, we created columns for noise 1, temperature, humidity, accelerometers, and the strain sensors as well. And the same for Unit 2. And after 1 month of testing, we collected 5,427 readings in Unit 1, and the same for Unit 2, as you can see here. And now we need to visualize the data. We used Grafana as an open source visualization application. And the first step was to connect the database to Grafana. Grafana has a feature to connect any database to the application by the username and the password of the database. And it has another feature to test if the connection is connected. As you can see here. The second step was to create 2 dashboards for Unit 1 and Unit 2, and to add visualization tables and graphs for each sensor to represent its data. Of course, all the graphs will represent the data sensors readings. Next, we will check the graphs we have made for this representation. Here you can see that accelerometer has X, Y, and Z to represent each parameter. And here is the noise sensor as well, which represent the noise range. Not to mention that all our sensors has been trained in rush hours and in the early morning to collect all the data during the day. Here the graphs for the humidity, temperature, and the strain sensors as well for Unit 1, and we did the same for Unit 2.
Here we can see the orange data mining map or design map that we have used to analyze the data using a machine learning algorithm. The machine learning algorithms that we have used from the classification algorithms, we have used the KNN, tree, and SVM algorithms. We can see the nodes on the left for Unit 1 and Unit 2, the input nodes. Each one of them has a healthy and not healthy data. We have added the not healthy data only to train the module, the classification module, and to get a better performance for a more accurate output. After that, we can see the merge node. The merge node only to merge the data that being sent from Unit 1 and Unit 2 and merge it, then send it to the three nodes for the classification algorithms, the KNN, tree, and SVM. Each one of them, of course, has its own advantage or its own way to analyze the data. We have also a scatter plot node. The scatter plot only to visualize the data that are being merged. After merging the data, we can see it as a visualized data. On the left side also we can see a geomap that is only for the location of the data that we took. This is the exact location of the data for the infrastructure. After that, all of the data, of course, we said is going to the machine learning nodes that we have, and it is the KNN and the tree and the SVM nodes. Each one of them has its own way.
And now we will see tree algorithm output. This algorithm split the data to best possible way and decide if the reading is healthy or not healthy. To train our system so it can detect not healthy data, we created abnormal readings, such as hit the rock of the infrastructure. And we even added heat source in front of our temperature sensor to read the data. So the machine can learn and decide if the infrastructure is in good condition or not. We used another algorithms such as KNN and SVM. KNN is the simplest algorithm. It classifies the data based on similarity measure. New data is classified by the measure values from three neighbors. Finally, for SVM, the goal of this algorithm is to create the best line or decision boundary so it can be split the data into classes so that we can easily put the new data points in the correct category in future.
Okay, and from here we can see that we have tried to detect the sensitivity of our 3ML algorithm. We have tried to input fake data, as you can see here, just to test the sensitivity, and on the next picture we can see that it generated directly alarms. So this way we can prove that the system is really sensitive. One of the most innovative aspects of our paper is that the novelty of our paper lies in providing a unified system to fairly compare performance of traditional ML algorithms to draw conclusions based on apples to apples and oranges to oranges. To add with, we have the innovative aspect of our design, which that we have used the LoRa with all the sensors in one system, and we were the first people to do that. From here we come to an end to our video. We hope you have liked it and thank you for watching.